Okay, guys, it's 9:03. I'm going to go ahead and start. And this is being recorded if it needs to be reviewed later. So today, y'all are going to do this lab 6.4.2 Etherchannel. I'm going to do the run through before I cut you guys loose to do it. But before I do that run through, I just want to take a minute and show you on the Cisco Networking Academy how you take the chapter test. Well, they used to be called chapter tests. There used to be a chapter test for each individual chapter. Now the Academy has broken this down into smaller modules, and there's a group test for the module. So the very first group test, let me show you how to get to that. So I'm logged on as a student user in Cisco Networking Academy, and here's our course. So I'm going to launch the course by clicking the Launch Course button. And I think I showed you guys last time that if you want to see the electronic ebook, you click on the Modules section, and then you click on this course content, and you have to click it about 2 or 3 times, and then you get the electronic ebook, the free ebook. The Cisco Academy has been giving you guys free ebooks for over 20 years now. But here's how to get to the what we used to call the chapter test, and now they're called the chapter module test. You click on the assignments, and then the very first test that we're going to take is modules 1 through 4, switching concepts, VLANs, and inter VLAN routing. We just finished that up last week. So to take that test, here's what you do. You click on that. What? I had it down here. I'll check that. But on the right-hand side of the screen here, you'll see a thing appears that says take assessment. Just like the old test used to be, the testing engine is just like the old Cisco Networking Academy test. You take the blue take assessment, and then it'll launch you into the test, and you can take the test stuff. I just turned that on. I don't know why that's off, but I'll check on that and make sure that's going. Most of you guys have not taken any of this test first. So my advice to you is I don't count off for late work. No discounts if you take it late, but don't put it off until the day before the final exam because it will be overwhelming for you. Okay. So here's the lab that we're going to do today, the 642 Etherchannel. It's in the student lab sections printouts of a MyTCC Blackboard. And now I'm going to minimize this. And in this topology for this test, it's like what we did last time with the spanning tree protocol. You have 2 switches connected together. And then there's 2 wires. So what's spanning tree protocol going to do when there's 2 wires? I've got these connected just like here, and I haven't done any configuration at all, except that I have gone onto the PCA and PCB, and I've set their IP addresses according to the front page of the lab, 20.3 and 20.4. And since the switches are unconfigured at this point, everything's in the default VLAN 1, everybody can hear everybody else. PCA is plugged into the left-hand switch. PCB is plugged in the right-hand switch. They ought to be able to ping each other. So if I go to PC1, or I'm mixing on PC2 right now, PCB, and he can ping PC1. I should be able to go to PCA, and he should be able to ping 192.168.20.4. So everything's doing just fine. Now we're going to go into the lab, and we're going to put them on their own VLAN 20. We're going to put the switches management addresses in VLAN 10. He has you create the garbage VLAN. He calls it parking lot. And he has you create a native VLAN 1000. So, and you have to do the tracking between the 2 for them to be able to communicate back and forth. So right now, default out of the box, they're working just fine. So on page 2 of the lab, go to our console ports. Oops, I mean this. What is the one thing you should always confirm and ensure before you start any Cisco Academy lab? 5, 4, 3, 2, 1. Thank you. I have some nice party gifts for you. You should make sure the devices are all set back to the default condition. So on a router, that's easy. You just type erase start and you reload the router. On a switch, we've got a couple things we got to check. So let's check these switches and make sure that they have no configuration on them. Appears to have the standard name switch. The default host name for a switch is the word switch. The default host name for a router is the word router. In today's lab, there's no routers. You're just going to be from your single workstation you're seated at now. You'll be able to do your switch A and switch B. So I'm going to go to the privilege exec mode, and I'm going to do a show the start command, and there's no startup configuration. And then the other thing I want to check is do the dir command or show flash command, and check for the presence of any file name called vlan.dat. Remember when I did the run through last week? I forgot to erase the vlan.dat file that was already there, and it was led to some confusion. Yeah, I'm the shoeless cobbler. I did not follow my own rules. So make sure there's totally, this one looks okay. There's no vlan.dat file present in that upper COM1 thing. Now let's go to the bottom switch. This top one is going to be switch 1 when it's configured. The bottom one is going to be switch 2. So I will go to the privilege exec mode, and I'll ask it to show me the startup configuration file, and there's not one there. Good. And then I'll do the directory command, and there is no vlan.dat file present. This switch is truly, completely, totally default, configured, erased, ready to go for our lab today. And we shouldn't have any conflicts with whatever was done with it on a previous lab. Okay, toward the bottom of page 2, he says we're going to assign the basic settings for each switch. So I'll start with switch 1, the one on the top, and I have to go to the global configuration mode, config T, configure terminal config T, and give them the host name S1. Prompt changes to S1. We have the word config after it that tells us we're in the global configuration mode. And now step 2B, let's do that command no IP domain lookup. So that way if you mistype a command and type it in, it doesn't hang the switch up for a minute or two and annoy you. I call that Cisco annoyances. No IP domain lookup. I can mistype a command and I'll instantly get my prompt back and I can type it correctly this time. Okay, .c, let's do that enable secret class command. Enable that's so whenever you go from the user exec mode to the privilege exec mode with the enable command, it will prompt you for putting in the password, and we always use the class as the password in Cisco Network and Academy. And we use the password Cisco for the console ports. Okay, let's do that next. Let's go line, console 0, password Cisco, and the login command said allow people to log in if they know the password is Cisco. Now let's go and do the same thing for the line VTY 0 through 15. Those are the telnet ports. VTY means virtual terminal. That's so you can, after the switch is configured and has an IP address, you can ping it. You can log into the switch if you know the passwords. And by default, we get the simple telnet, but normally in good practices, we'd use secure shell instead because that's encrypts the data. Okay, I'll type login first, like I did last time. Oh, he complains because I enabled logins, but no password has been set yet. He won't actually work if there's no password set. He won't allow you to log in at all. That's a security feature. If a device is unconfigured, he won't allow you to log in unless someone has configured the password. So password Cisco. Okay, step 3. I'll go back to step 2 in the middle page and do the switch 2 when we finish the switch 1. Okay, the command to enable. If we do a show run right now, the enable secret class word is encrypted. It has that number 5 and that encrypted code after it. You can't look at that and just discover, oh, it must be class. You can't tell. But all the other passwords, they're at the bottom. Password Cisco, password Cisco. It's in plain text. So this command, service password encryption, that will encrypt those commands so you won't be able to see them anymore. Okay, so I applied service password encryption, and now when I do show run again, look, they're encrypted. You can't see them anymore. You can't see that they're Cisco. Okay, I'll do a banner message of the day, config T, oops. The banner message of the day, In the lab, he uses the delimiter character of the $sign. Typically, we use the £. Any delimiter character works with binary message of the day. Just has to be a character that doesn't appear in the message itself, because then he'll interpret it as you won't see anything after that. So I'll say, whatever you want your nasty message to be. And then they'll see that before they ever log in. You have been legally warned. Do not log in unless you're supposed to be here. Now we're supposed to save the configuration. So copy, run, start, and save. I'm not going to mess with the clock. You can skip that step if you want to. These devices have, like PCs, desktop PCs, have a built-in battery backup clock. And for purposes of this lab, it doesn't matter if the clocks aren't the same on both machines. Network time protocol, it matters, but we'll get that in another course. Okay, I'm going to go back and do the same thing on switch B, switch 2. So go to the configuration mode, hostname S2, no IP, domain lookup, enable, secret, and the passwords class, line console 0, password Cisco, login, and then line VTY 0 through 15, which means that, remember, computer science professors ask them to count to 5, and then we'll go like this: 0, 1, 2, 3, 4. So 0 through 15, how many telnet lines are there that can be simultaneously used? 16 of them. So password, Cisco, login. I will skip the service password encryption and binary message of the day on this one because we already saw it on the other one how that works. And then I'll do a copy, run, start. The shorthand Gonzo abbreviation shortcut deprecated. Old command was write mem, which can be written as WR for write, and that'll do a quick copy, run, start for you. You only have to press enter one time. Okay, step 3, configure the PC hosts. I already configured the PC hosts. And when we did IP config on them, bring focus. So PC A was 192.168.20.3, and when we pinged 192.168.20.4, it worked. So PC A and PC B, I did that ahead of time just to save a step. So the PCs are okay. Okay, let's go back to our switch consoles. Okay, I'm in the middle of page 3. Part 2, we're going to create the VLANs and assign switch ports to the VLANs. They have this chart on the front page. In this lab, all the commands have been given as a command review. So there's pretty much nothing for you to answer on this one. Just do it, write your name on the paper, and turn it in. So let's do switch 1. We're going to go to the global configuration mode. Interface, I'm sorry, VLAN 10. Name, management, manglement. Yeah, they're the managers mangle things. VLAN 20. Name, clients. That's our PCs, our host PCs. A and B are going to be in that VLAN. VLAN 999. Name, parking lot, and name. I'm sorry, VLAN 1000. And we're going to make that our native VLAN. Just calling it native doesn't make it native. We're going to type in a command to do this. Okay, I'm supposed to repeat this now on switch number 2. And we're not using VTP anymore because it's no longer a requirement. So I'll have to retype the commands. Now imagine if you had to put 20 VLANs on 20 switches. So it's a CCNP topic, but used to be a CCNA topic. I could do it on one switch and then have that switch propagate the list of VLANs over to the other switches and save me a little bit of typing. Maybe I won't make a mistake. So configure terminal from switch 2, VLAN 10, name, management, VLAN 20, name, clients, VLAN 999, name parking lot, and VLAN 1000, and that's going to be named native. Now let's put our management addresses on our switches, our so-called SVI, switch virtual interface management address. By default, it's VLAN 1. We ain't going to use VLAN 1. It's considered bad practice. We're going to put it in a different VLAN and isolate it from all the other guys so we can apply some security to our IT guys, and other people can't try to break into our switches and do stuff. Just because they took 2 weeks of a Cisco Network Academy class, they think they're hot something, they can try to break into our system. We're not going to allow that kind of stuff. We're not going to put up with that. Okay, I'm on switch 1, and I'm going to say interface VLAN 10. Config-IF. We're in the sub interface mode of the global configuration mode. And IP address is stated to be, this is on the front page of the lab, it's also here, 192.168.10.11, and our normal 255.255.2, /24 subnet mask. And perform the no shutdown command. Now I'll go to switch 2 and do the same thing on him, interface VLAN 10, give him a slightly different IP address. 192.168.10.12. If I had accidentally configured them both with the IP address, I would start getting error messages that the two devices had detected duplicate IP addresses. If you try to do it on a Windows computer, the Windows computer puts an error message on the screen and says, "I'm taking my toys and going home." Actually, he puts up a message that he's shutting off the network because he's detected a duplicate IP address. So that's the venial sin. Is that a venial sin or a mortal sin? You Catholics, you can't do that in networking. You can't have duplicate IP addresses, or the system shuts down and doesn't work properly. Okay, I'm already on switch 1. I did the no shutdown command. And so let's go back to the configuration mode. And what we're going to do is put all the ports that we're not using, which is port 6 and port 1 on the first switch, and ports 1 and 2. And on the second switch is port 1 and 2, link the two switches together. And port 18 is the one on the second switch that goes to our PCB. And we're supposed to take all the other switch ports and put them away in a VLAN that doesn't connect anything in the company. So if somebody breaks in the wiring closet and plugs into an empty switch port, they have no connectivity, they can't mess with your system. Okay, interface range, fast Ethernet 0/3 through 4, that -4, comma, fast Ethernet 0/7 through 24, comma, and gigabit Ethernet 0/1 through 2. He doesn't like my gigabit. Oh, what? Oh, let's see. What did I type in correctly here? That's supposed to be a comma. And then gigabit 0/1 through 2. Okay. Okay, good. So switch port, mode, access. They're all access ports, not trunking ports. Switch port, access, VLAN 999 is our garbage VLAN. Okay, good. They're all placed in the garbage VLAN. Now let's go to the second switch and do the similar command. Second switch is slightly different because port 6 is not used. Port 18 is used for the host machine. Configure mode, interface range, fast Ethernet. Okay, switch 2, F0/3 through 17, comma, we got to skip 18, F0/19 through 24, comma, I talked to comma that time, and the gigabit 0/1 through 2. Oh, what did I do wrong here? Oh, interface range, okay, let's see. Try again, interface range, fast Ethernet. Oh, I typed it twice. I typed fast Ethernet twice. Okay, fast Ethernet 0/3 through 17, comma, fast Ethernet 0/19 through 24, comma, ngig 0/1 through 2. Okay. They only do what you tell them to, not what you command them to. Syntax matters. And we're going to do the same thing here. Switch port, mode, access, port access, VLAN. That's a 999, wasn't it? Switch port access, port access, VLAN 999. Okay. Well, let's check and make sure that took effect. I could do show VLAN. So the 10 is our management VLAN. That's going to be the switch management port. 20 is our clients. We haven't done the step yet to move port 18 to that client one yet. We're going to do that in just a second. On the first switch, I'll do a show VLAN. Port 10 is a management. 20, we're going to put port 6 of this first switch into 20, VLAN 20. We're going to put port 18 of the second switch in the VLAN 20, and then they should be able to talk to each other after we set up trunking. Okay, it's time to do in the middle of page 4, it's time to assign that port 6 on the first switch and port 18 on the second switch into VLAN 20 so that they'll eventually be able to ping each other. So I'll go to the config mode, interface, fast Ethernet, 0/6, port, mode, access, switch port, access, VLAN 20. They're in 20, aren't they? Yeah. And if that worked, when I do show VLAN, yeah, port VLAN 20, the client's PC is showing that port 6 is present in there. And we'll do the same sort of everything on the second switch, except it'll be on port 18 for the second switch. He's in a different port. So configuration mode on the switch 2. Turn off my caps lock. Interface, fast Ethernet, 0/18, switch port, mode, access, switch port, access, VLAN 20. And if that worked, when you show VLANs, we should see that port 20 has 18 in it. Okay, so they're proper now. The PCA is connected to switch 1, the top switch, to the client's VLAN 20, and he's on port 6. And PCB is connected to port 18 of the second switch, and he's been assigned to the client's VLAN, VLAN number 20. And eventually they'll be able to ping each other. They can no longer ping each other right now because the 2 wires between switch A and switch B are still access mode, port 1, VLAN 1. We haven't made them trunking ports yet. The ping will fail. So let's fix that by doing the trunking now. Okay, so I'm on the middle page 5. And we're going to configure the 802.1q trunks. And he has one way of doing it. I'm going to go ahead and use his way. I don't like the desirable, all this other stuff, but I'm going to go ahead and use this way to do exactly what the lab says. So at part 3, step A, we're going to do the interface range command. Configure mode. Block again. Okay, interface range fast Ethernet 0/1 through 2. And let's do switch port, mode, trunk. I'm going to bundle them together. He actually go ahead and bundle them right now as trunks. You can actually do it later. It'll work just as well, but that's the way he does it. I'm going to follow his instructions. Next, second switch, config T. Interface, range, fast Ethernet 0/1 through 2. Switch port, mode, trunk. Okay, now we're going to set the native VLANs because it's a good practice to not use the default native VLAN number 1. I'll do it on switch. I'm already at switch 2. I'll do that first, and then I'll jump back to switch 1. Oh, I was in the. Let's see if I can go back to the configuration mode. I should be able to use the up arrow key. Okay, and not have to type all that in over again. The up arrow key repeats previous commands. So that saved me from having to type that, and it's so easy to make mistakes when you type long commands. Okay, switch port trunk. Native VLAN 1000 is our native VLAN. Now we're going to get lots of error messages here until I fix this on the other one. Config T. Let's see, interface range, there it is. And switch port, trunk, native, VLAN 1000. And the coffin stopped. The error messages should stop. Okay, now another command I haven't illustrated yet ever, and now we'll see it in this lab. At the bottom of page 5, it is possible, by default, all VLANs are allowed in the trunk. But we're going to specify which VLANs we want. We can sort of trim the traffic from a VLAN that maybe goes across the street to the engineering lab. We don't want to waste traffic across that fiber optic cable. So we can specify which ones are actually allowed and not allowed. So I'll go to switch 1, and I'll go to the configuration mode, and I'll say switch port, trunk, allowed, oh, switch port, wasn't in the range, there we go. Switch port, trunk, allowed, VLANs, which VLANs? 10, 20, 1000. Note what VLAN was not allowed. We made 4 VLANs. Which VLAN did we fail to include to be allowed? 999, the garbage hole VLAN, the parking lot VLAN is what he called it. So someone plugged their machine into a port. If they're an outside intruder, I'm sorry, we can't call them malicious users anymore. It makes them feel bad. We have to call them threat actors now. If they plugged into an empty port, then there would be no connectivity. Okay. Oh, good, my mic's still on. I turned my mic on the lecture yesterday, off for about 5 minutes, and everyone's going, what's he talking about? Okay, and I'll repeat that command on, oh good, I'm already in this, so I should be able to type switch port, trunk, loud, VLAN, 10, 20, 1000. 999 being excluded again. Those should always match when you do those on two of them. Okay, is we really trunking? Let's check and see. The official command is show interface trunks. And we see that ports 1 and 2 are trunking. Should be the same on the second switch. If they weren't the same, we would be seeing lots of error messages. Show interface trunks. So we have consistent information on both of them. We're going to make them a port channel, a channel group now. So the reason being, if we just left it like this, it would work just fine. But when I show the spanning tree protocol, remember spanning tree protocol? So the root bridge, well, root bridges don't have root ports. So the top one's the root bridge. The top one is not the root bridge because it's a root port, but it has a port that's in the alternating or block state. Port 2 of the first switch is being blocked because it would create a loop and broadcast storms, and that can't be allowed to take place. And we're losing half our bandwidth. We only get 100 megabits of bandwidth. I'd rather have the 200 megabits of bandwidth, because these computer science Cisco guys create a lot of traffic. You know, when they go to the Cisco Academy, we need to fix that. So we're going to do this at the bottom of page 6. And he's going to do it on switch 1 first. So go back to the configuration mode and go back to the interface range, fast Ethernet 0/1 through 2. Now we're in the prompt config-is range. And channel group 1, the number 1 must match on both of them, or they won't get the group to talk back and forth. Mode, here's the choices. He says use active. 2 actives will channel group up with each other. I like to type on to make it unconditional, but I'm going to do what he says. I'll make it active. That should cause it to take place. But creating a port channel. Now he's freaking out because the port channel is not yet being created on the second switch, so let's do that on the second switch. Configure terminal interface range, fast Ethernet 0/1 through 2, channel group 1, active. I'm used to typing mode. we'll see error messages and some status messages. LACP, the link aggregation control protocol, is negotiating between the two of them, and it should die down after a second, and they should be all trunked up now. So let's repeat the command that we did before. Show interface trunking, and it used to be FA0, 1, and 2. Now it's port channel 1, which is composed of FA0, 1, and 2, but the bandwidth is greatly increased. Show interface trunk. Port channel 1 is being created. Now, in the alternative, show interfaces status. I like this command because it shows us that you can look at a glance. This doesn't work on Packet Tracer. Packet Tracer will always show us as a VLAN 1, even if you do the command. It'll work, but this command is improper on Packet Tracer. On this real machine, it really works. Port 1 and 2, we set them to trunking. Yeah. Port 20 on this switch is the access mode for PCB. And port channel 1 at the bottom, trunking, connected at full speed. Okay, how about the command show Etherchannel summary? It's working. At the bottom line, group 1 is being created. Port group number 1. It's P. It's working. It's positive. If it had been some other indication there, it's not working properly. So it's working properly. P means bundled in the port channel. It's working. Okay, I've gone through the whole lab there. Okay, let me stop my recording.